What is nano? A man's beard grows 5 nanometers every second. Oh, suffice it to say, a nanometer is very, very small. Despite its size, you can see the effects of things happening at the nanoscale all around you. They give the sunset its red colour, allow birds to navigate, and help geckos stick to trees. But it's only recently that we've actually been able to see down to the nanoscale. This is Nano You. We humans are strange creatures, aren't we, if we're honest? We like to measure things. Earth's tallest mountains are over 8,000 meters tall. A football pitch is around 100 meters. I myself am about 2 meters when I'm standing up, in shoes. Good afternoon. Ants are a few millimeters long. Skin cells about 30 micrometers. We can't see things this small. A bacterium is about 2 micrometers. Smaller still are viruses and phages. And so we go down to DNA, our molecular blueprints. DNA is 2 billionths of a meter in diameter, or more conveniently, 2 nanometers, the units that we used to measure the building blocks of everything. Welcome to the nanoscale. To explore the nanoscale, we use very powerful machines called electron microscopes.
Today we're going to look at 2 things that you may have seen before. We're going to look at a fly and a coin. So this is the Z on the coin. This is the fly's wing. And who would have thought that it would have had all these little hairs sticking out from it? The tip of each of those hairs is only about 600 or 700 nanometers in diameter.
When we use electron microscopes, we explore new and alien landscapes. It's a strange new world down there. The nano world isn't just unusual looking, things behave differently there too. One reason for this is surface area. If you take a cube and lay the surface flat, you can see how much of that cube can react with the outside world. If you divide the same cube into 8 little cubes, the surface area is twice as big. If you keep making smaller cubes, the surface area becomes immense. More surface means more area for reactions. This is why powdered sugar dissolves faster than sugar cubes. Big lumps of aluminium are not very reactive, but nanoparticles of aluminium are so reactive they can be used in rocket fuel.
Another way you can show this is with flour, because flour doesn't burn very easily when it's in a pile, because it hasn't got enough surface area. But if you mix it with a lot of air, then something quite different happens. Ow.
Light also behaves differently as you head down to the nanoscale. White light contains all colours. When particles get really small, they start to bounce only certain colours back, so you see them as those colours. As gold gets smaller, it stops looking gold and instead reflects red, purple, blue, and finally becomes invisible when it's too small to reflect any colours of light that you can see. These strange properties of light can be very useful.